Hello everyone, hope all of you are doing great, and in today's video we are going to discuss a few concepts and skills from algebra. Alright, the first question over here says to you, if a equals -2 and b equals 3, find the value of this expression. So the first thing that you're supposed to do, and slowly, step by step, is to substitute. So a is actually -2, so it's 2 multiplied by -2. 2 multiplied by -2 is going to give you -4. Plus, b is 3 squared minus 4 multiplied by a. So 4 multiplied by a, as if you're saying it's -4. It is not just a 4. Be careful with this. So it is -4 multiplied by -2. So this is going to lead to +8. Negative times negative is positive. So here is -1 squared plus 8 equals 1 plus 8 equals 9. The next question here says to you, if m equals -4 and n equals 2, find the value of this expression. Well, I'm going to do the same thing exactly. 2 multiplied by m is -4. -4 squared, slowly and step by step. -4 squared is 16 over n, which is 2, plus n, which is 2 squared, n squared, so it is 4, over m, which is -4. This will lead to what? 32 over 2 plus 4 over -4. So it is 16 plus -1, which is -1, equals 15. Square root of p, which is square root of 16, plus cubic root of -27. So it is 4 plus cubic root of any negative number stays the same, negative. So 4 plus -3, which means 4 minus 3, it's just 1. Here, the 2, if you multiply it by -3 cubed, then minus k is -3 plus 1 squared. So it is 2 multiplied by 27, -27. -3 cubed is -27, minus -3 plus 1 is -2. So -2 squared is +4. -2 squared means -2 times -2, which is +4. But the negative outside the brackets remains the same. Equals, I must finish multiplication first. So 2 times -27 is -54. Minus 4 equals -58. Write an algebraic expression for the product of a number, which is x and 5. Product means multiplication, so it's 5x. Increased by 9, so plus 9. Write an algebraic expression for 7 more than 3 times a number y. So it is 3 times the number y, 3 times the number, so it is 3y. But 7 more than it, so it is 7 plus 3y, or 3y plus 7. It doesn't really make a difference. 3y plus 7. Write an algebraic expression for the cube of a number m, so m cubed, decreased by 4, then minus 4. Then a rectangle has length x plus 6, width x plus 1. Write an expression for the parameter. Mister, I know that the parameter is 2 multiplied by length plus width. So the length plus the width doubled. So I'm going to do the same thing. 2 multiplied by x plus 6, which is the length, plus x plus 1, which is the width. All right. Here, it is still 2. Finish what's inside the brackets first. 2x plus 7, collecting like terms. Expanding the brackets gives you 4x plus 14. You want to leave it factorized, fine. You want to expand it, also fine. Both are correct. A triangle has side lengths 3a, a plus 5, and 2a minus 4. Write an expression for the parameter. We know that the parameter of any other shape or any shape is adding the length of all the different sides. Adding the length of all the different sides. So here, the first side is 3a plus the second side, a plus 5, plus 2a minus 4 equals 3a and a is 4a, 4a plus 2a is 6a. Positive 5 minus 4 is positive 1. We collected the like terms. A square has side length y plus 5. Write an expression for the parameter. Well, I know that the square has 4 sides, and the 4 of them are equal. So just saying 4 multiplied by y plus 5, which is 4y plus 20. Some of you might have thought about it that, oh, I have y plus 5, I'm going to write it 4 times and add them to each other. Well, that is fine, but actually, why would you do all of this? It is just a 4 multiplied by y, 4 multiplied by 5 is going to give you the same answer exactly, which is 4y plus 4 fives, which is 20, the same thing. Question 11. Here they gave you the length and the width. Write an expression for the area of the rectangle. We know that the area equals length times width. So the expression must be length multiplied by the width. But now I need to expand the brackets. So it is x squared, first by first, then first by second, negative 2x. Second by first, positive 7x. Second by second, negative 14. So x squared plus 5x minus 14 is the expression for the area. Here, they're telling you it is a triangle, and they're giving you the base and the height, and they're requesting an expression. We know that the area, an expression for the area, we know that the area of a triangle is half times base times height, half BA or BH over 2. All right, I'm going to do a Mr. Half, or let me just try the other root, BH over 2. I prefer the second one actually. It's going to help you a lot. Or the first one is not going to be wrong also. It's going to be the same answer exactly. So base times height, which is 4b, multiplied by b plus 6 over, this is now base times height over 2, equals, you can simplify the 2 first with the factor, and it is extremely important that you simplify it with the factor, not with the 6 that is inside the brackets. No, it is with the factor that is outside. And then you write it is 2b multiplied by b plus 6. Correct. You can leave it this way. You can start expanding. It's up to you. Some other people might think about expanding first. 4b squared plus 24b over 2. And they think about simplifying. So dividing this by 2, dividing this by 2 as well. Both of them divided by 2. So 2b squared plus 12b. Also correct. It is the same as the first one exactly, but after expanding the brackets. A rectangle has area. Okay, this is 4x to the power of 2, okay? 4x to the power of 2 plus 20x. And width is 4x. Write an expression for the length of the rectangle. We know that you should know that the length is the same as area over width. The area is 4x squared plus 20x. over the width, which is 4x, equals. Now, how can I simplify? You can simplify by dividing both of them by 4x, accepted, but at the same time, you can simplify by factorizing, which is what's mathematically more accepted. You factorize the numerator first. Then inside the brackets, you're going to have over here 4x squared divided by 4x is just x. 20x divided by 4x is just 5. Then over 4x. This way, you simplify the denominator with the factor. So by equals x plus 5. Referring to question 13, if x is 3, find the parameter of the rectangle. Well, referring to question 13 over here, if x is 3, then the length, which is actually x plus 5, we found that it is x plus 5, and the width, which is 4x, was given already to us. Then the length is just 8, and the width is 12. Well, let me tell you just something that is not going to affect our answer, but this should have been switched. This is what we call actually the length, and the other is the width, because the length is the long one, the width is the short one. It doesn't matter actually right now. It is a mistake because I'm the one who made the question, not Cambridge. So here, to find the parameter of the rectangle, we said it is 2 multiplied by length plus width. So it is 2 multiplied by 8 plus 12, which is 20. So the parameter is 40. You should remember this rule. For the parameter, it is length plus width multiplied by 2. For the area of the rectangle, it is just L times W, which is length times width. Study and remember these two rules. Simplify this. We agreed we need to factorize the numerator. So factorizing the numerator, you're going to find that the only factor that you can get out is the x squared only. So 8x, I took already x squared only, so x is to the power of 6 divided by x squared is x to the power of 4. Be careful when factorizing. You must learn how to factorize. All right, I'm sorry, guys. This is multiplication, not addition and subtraction. So just a second, let me erase this. So here you just multiply. 8 multiplied by 3 is going to give you 24. X to the power of 6 multiplied by x to the power of 2 is x to the power of 8 over 4x to the power of 3. Now you can simplify even more by dividing. 24 divided by 4 is 6. X to the power of 8 divided by x to the power of 3. We've subtracted the powers. It is x to the power of 5. The next one over here, the 2 is squared, and the x to the power of 5 is also squared. So be careful with this, please. 2 squared is going to give you 4. X to the power of 5 also is squared, so it is x to the power of 10. Question 17. I don't know what happened to the Q. All right. Y to the power of -4, they want you to write it as a fraction. Well, as a fraction, it is 1 over y to the power of the -4. When you flip the number, or when you flip the whole thing, the negative index changes into a positive index. So the same thing exactly if they were saying to you, for example, x to the power of what equals 1 over x to the power of -7. So it is x to the power of 7 is the same as 1 over x to the power of negative 7. Here, it is 3 to the power of negative 2 multiplied by 3 to the power of n, which means that the negative 2 is added to the n. Divided by 3 to the power of 4, which means negative 2 plus n, then minus 4, equal to 3 to the power of negative 1, which means that they're supposed to give you negative 1. Solve the equation normally. Negative 2 and negative 4 is negative 6. So n minus 6 equals negative 1. Send the negative 6 to the other side. You're going to find that n equals, sending it definitely with the opposite sign or the opposite operation. It is negative 6. It goes there positive 6. So it becomes 5. You want to check? Not a problem. Negative 2 plus, because it's multiplication, 5 gives you 3. Then 3 minus 4, because it's division, gives you the negative 1. Expanding brackets, we've just practiced this a few minutes ago. X multiplied by x is x squared. Then x multiplied by positive 2 is 2x. 6 multiplied by x is 6x. 6 multiplied by 2 is 12. Then x squared plus 8x plus 12 is the answer. Here you're going to follow the same steps exactly. Here, this shows x minus 7 multiplied by itself. So please don't just go and write x squared plus 49, because x is squared is x squared, negative 9 squared is positive 49. No, this is not how it works. Please do not do that. X minus 7 all squared just simply means x minus 7 multiplied by itself. So now expand the brackets of the same technique exactly. X squared minus 7x minus 7x positive 49. So it is x squared minus 14x plus 49. In this example over here, you can do both ways. The first way is that you multiply first by first, like what we've done, which is x squared, and first by second, which is negative 9x, then second by first, which is plus 9x, and second by second, which is minus 81. But you will find at the end that this cancels this. So it is x squared minus 81 right away. Yes, but at the same time, I wanted you actually to learn an easier way when you have the numbers in the brackets exactly the same, but the signs are different. Remember this. This is positive, this is negative, but x is x and 9 is 9. Only the signs are different. Just multiply first by first and second by second. That's it. You got the same answer. Okay, this works only if the two brackets have the same numbers and the same values exactly, only the signs are different. Here, we're going to use what we learned in question 22 to answer question 23. So we learned that if they have the same values exactly, the same exactly, but different signs, I multiply first by first and second by second only. So here this is what? Square root of 17 plus 7 multiplied by square root of, they said x is 17 minus 7. First by first, square root of 17 multiplied by square root of 17 is just 17, mister. Then 7 times negative 7 is negative 49, mister. So 17 minus 49 is going to be negative 32. That's it. Okay? Do not start with first times first, then first times second, and second times first. Why would you do that? We already learned that multiplying first by first, second by second only works if both terms are the same exactly inside the brackets, but different signs. If the signs were the same, this trick wouldn't work. If this was positive, this was positive, or if this is negative and this is negative, this wouldn't work. You would have needed to follow first by first, first by second, and so on. And I'm sorry, just don't forget that any root, any square root multiplied by itself will always give you the same number that is under the root. It should give you square root of 64, which is just 8. Simplify this. The denominators are the same. So thank you. This is very easy. Just add the numerators. 2x plus 5x is 7x. So 7x over 7 is just x. Here, the two denominators are not the same, mister. We know and we learned that we must make the denominators the same in addition and subtraction. So multiply this up and down by 2, gives you 2y over 8 plus y over 8 equals 3y over 8. That's it. Same thing here, multiply up and down by 2, gives you 6x over 16 plus 5y over 16 equals, mister, how can I add 6x and 5y? They are not like terms. Never think about 11xy. Don't even think about it. We cannot add them. They are unlike terms. So 6x plus 5y over 16, and this stays the same. Over here, you need to multiply up and down by the other denominator, which is 2y up and down, and 3x up and down. This should give you here 14y over 6xy plus 15x over 6xy equals. Now the denominators are the same, mister. Perfect. So let's start adding. 6xy stays the same. 14y plus 15x, we do nothing about them. I can't. Simplify this. You should factorize the numerator first. How, mister? You can take the 20 out. So it is x plus 20. So now 20x divided by 20 is just x. 40 divided by 20 is just 2, sorry. It is 2. Over 10. Now we simplify the denominator with the factor, only the factor. So you factorize the numerator, then simplify the denominator with the factor. So bye-bye, and this becomes only 2. So it is 2x plus 2. You leave it this way, or you can expand whatever. Same thing over here. Factorize the numerator. Take the 6x out. And then 12x squared divided by 6x is 2x. Then plus 1. 6x divided by 6x is 1 over 18. Can you simplify anything from the factor with the denominator? So we'll simplify the factor with the denominator. Yes, I can. Divided by 6 is going to leave the x alone. And dividing it by 6 is going to leave it as 3. And this is the simplest form. Oh, mister, so I do not have actually to get rid of the denominator completely. You don't have to. You have to simplify if possible. So that's the simplest form we can reach. Now, with making x the subject of the formula, you need to check what is the last thing that happened to x. X got subtracted, we subtracted from it 5, then we divided by 4 after that. So the last thing that happened is divide by 4, send it to the other side, multiply by 4. So it is 4y equals x minus 5. Now I send the minus 5 to the other side, plus 5. So it is 4y plus 5 equals x. Now we made x the subject. Same thing over here. Ask yourself, what is the first thing that happened to x, then the second, then the last, and then start sending the last. So here, x, the first thing that happened to it is that it got squared. After we squared the x, we multiplied the result by 4. After we multiplied x squared by 4, we took all of that and we added to them 7. So start with the last thing that happened. Add 7 goes there, subtract 7. Then now, the last thing that happened to x, x got squared, they multiplied by 4. So send multiply by 4 their division. Now it is the square. Send it over there, square root. And here is the trick. Most of you, unfortunately, send the square carelessly this way. A minus 7 over 4. They send the square over here and they just write it this way. And they find it that they got it wrong. Or they lose a mark at least. So why is it wrong? Because I'm going to send the square to the other side, square root over the whole fraction. So just extend it a little bit down. Oh, Mr. Seriously? I just needed to make it taller, longer? Yes, exactly. You needed to do that. So, because what you've done in the beginning was square rooting only the numerator. But I need to square root the whole fraction. So x equals square root of everything a minus 7 over 4 this way. Now we need to collect like terms. So here, this is x squared with this the x squared and this the x squared. Well, they're not going to come and say to you collect like terms, to be honest with you. They will not say that. All what they will say is just simplify. Only. How can I simplify that? Just to collect like terms. Even though this is very simple and easy, but some of you actually think about it, oh, I'm going to send the 9x squared negative 9x squared. Why? Why would you do that? They are on the same side. It's not an equation and you're going to send something to the other side of the equation so you change the sign. No, they're just all on the same side. Nothing changes. So it is 9x squared plus 3x squared, which is 12x squared, minus 2x squared is 10x squared. Positive 4x minus 6x is negative 2x. Negative 7 and positive 5 is negative 2. Then you leave it this way. All right, let's continue. Solve the following simultaneous equations. Look at this here. I must first look for something that helps me eliminate. I'm going to use the elimination method. How did you know? Because x and y are both on the same side in both equations. So look at this. Once you find that x and y are on the same side of the equations, which is the left side here, then it's elimination method. But ask yourself, are they ready for elimination? How can I know if they are ready for elimination or not? Ready when the coefficients of one of the two variables are the same. What do you mean, mister? The coefficient is the number that is next to the x. So are they the same? Here I have a 2. Here I have also a 2. No, mister, I have a 5. So not ready for elimination. The x is not ready. The y. Do I have here a 3? Do you also have here a 3? No, mister, I don't. So they're not ready for elimination either. How can I get them ready, mister? Multiply one of the two equations by a specific number. So if you multiply the first equation, all of it by 2, this will make the y have a coefficient of 6, just like the other equation. So I multiply by 2 to make the coefficients the same. And this way I will eliminate the y's. So multiplying the whole equation by 2 gives you 4x plus 6y equals 26. Then the second equation, I will not touch it. 5x minus 6y equals negative 8. Now ask yourself, do you need to add the two equations for elimination to happen? or you need to subtract the two equations for the elimination to happen? We're going to eliminate the y, we agreed. So if we say 6y plus negative 6y, yes, this will eliminate them. So the plus works. Unlike subtracting, if you say 6y minus negative 6y, no, this is not going to help you eliminate. The subtraction will not help you eliminate because this will become plus. It will become positive. So it will be 12y. So let's start now through addition, which will help us eliminate. 4x plus 5x is 9x. 6y plus negative 6y, bye-bye. 26 plus negative 8, which means 26 minus 8, is going to give you exactly 18. So x equals 18 divided by 9, which is just 2. Take this and substitute in one of the two equations. So taking the first equation, for example, 2 multiplied by 2 is 4. I know that x is 2. Plus 3y equals 13. So 3y equals 9 and y equals 3. You want to check there? Fine. 2 multiplied by 2 is 4. Or in the second equation, 5 multiplied by 2 is 10. 3 multiplied by negative 6 is negative 18. So 10 minus 18 is negative 8. It worked. Over here, you're going to follow the same rule exactly, the same steps. I need to eliminate the x's, then multiply down by 2 if you need to eliminate the x's. If you need to eliminate the y's, then multiply up by 2. And follow the same steps exactly as in question 33. Question 35 here, it is a little bit different. Here they're giving you the y equals 2x plus 1. So I'm going to use the substitution method. How, mister? I'm going to take y because they said it is equal to 2x plus 1, and I substitute in the second equation. I remove the y and write 2x plus 1. So it's 3x plus, and instead of y, I'm going to remove it and write 2x plus 1. They said to me that y is 2x plus 1 equals 11. So 3x plus 2x is 5x plus 1 is 11. So 5x equals 11 minus 1, which is just a 10. Oh, no, we're not done. We need to find x is 2. Please do not leave until you find y. What is y going to be equal to? So here you're going to find that I take y equals to 2x plus 1. But in this case, I remove the x and I write 2. So y equals 2 times 2, which is 4, plus 1. So y equals 5. By the way, guys, in the simultaneous equations over here, they might change the order. Like, for example, they write to you 3y plus 2x equals 13, and the 5x minus 6y equals negative 8. You just rearrange it to make the x's on top of each other and the y's on top of each other, just to switch the x with the y here. And even if they put the x on the other side, bring it back here with the opposite sign. The last question over here is for the graphing method. So complete the table of values for y minus 2x equals 6. When x is negative 4, done for you. When x is negative 2, then y negative 2 times negative 2 is positive 4 equals 6. So y equals 2. When x is 0, then y equals, this will be bye-bye. So definitely do not cross it out this way. Y equals 6. Now, they have given you already the graph of this. equation, 4y minus x equals 7. It is a different equation. This is not the same one as what we were doing over here. It is not the same. But they are requesting from you to draw the line of y minus 2x equals 6 on the same grid. Y minus 2x equals 6, we've just done it. It is through this table. Just plot and connect. Let's do it. -4, -2 is here. And then -2, 2, -2, 2 is here. And the last one is 0, 6. 0, 6 is here. Then all what you need to do is just to connect them this way. Just a second. Here you go. Connect them accurately. Done. All right. Then after that, you will notice that the two lines intersected. The line that we've just graphed, the line that we've just drew right now, is actually which line? You're going to find that it is, one second, it is the line y minus 2x equals 6. So now I have two lines with two different equations. They want you to use the graph to solve the simultaneous equations, this and this. Don't go and use the substitution method. Please don't. No. They requested from you to draw the graph. You drew the graph already. So don't waste time on solving the simultaneous equation using the elimination method. Just check the point of intersection of the two equations. Both equations, through the lines, they intersected at this point. Then go down and you're going to find that the x is here and the y is here. Noting that this is going to be the second line after the -2, so it is -2.2, -2.4. So x is -2.4, and the y is 1.2. This way, you solved the simultaneous equation using the graphing method. Mister, how did you know that this is 1.2 and this is not, for example, -2.1? How did you know that it's not -2.1, -2.2, because if you continue, you're going to find -2.3, -2.4, -2.5. Is this really -2.5? No, 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 mister. Okay, now I understand. Actually, we are just jumping over here in 2/10. So it is -2.2, -2.4, -2.6, -2.8, then -3. That's it. Thank you so much, everyone, and see you in another video.